Anton Garrett, you are a living link with some of the greats of probability theory, especially E.T. Jaynes and David Stove. Could we start with Jaynes? Could you tell us about how you came to know him and what you thought his basic message was?
Yes, certainly. I was working at Cambridge for my doctorate on electron physics of the ionosphere, that's the upper atmosphere. And to improve on what had been done in the 1930s, it was necessary to go to a deeper level of description, which is called a kinetic theory. And that involves taking an average and looking at what your average electron will do. Because remember that the electrons and the molecules of gas in the atmosphere are actually moving at hundreds of meters per second, but you don't feel a wind blowing that quickly. And so some kind of averaging process you have to do. And that averaging process involves probability, I became convinced. And Ed Jaynes was a man who said that you needed to do that averaging using probability rather than other methods that are known technically as ergodic theory. And I became convinced that Ed Jaynes had the key to what's called statistical mechanics, which was the area of physics you need. And obviously, as I mentioned, probability, then probability was in there as well. I also became interested in the foundations of probability theory. And that led me, via Ed Jaynes, to the work of R.T. Cox, as I like to call him.
Okay, maybe Cox is the earliest and most basic of those. Can you tell us in the simplest terms you can what Cox said? Or give us a few sentences on who he was and then what his paper said.
Oh, I'd be delighted. Unlike Ed Jaynes, I never actually met Richard Cox, but they're both great intellectual heroes of mine. Cox realised that what are probabilities of? It's the probability that it will rain here tomorrow at midday. Now, that's either true or false. Now, true or false propositions obey an algebra. That's the Boolean algebra that computers run by, and binary logic. And if the probabilities are of the propositions, and if the propositions obey a Boolean algebra, that means that the probabilities have got to obey some kind of algebra.
By Boolean algebra, you mean and, or, and but?
Yeah, exactly.
Yes.
And Cox, in 1946, showed that the laws of probability are what probabilities have to obey if they are to be probabilities of binary true or false propositions. That's oversimplifying it a bit, of course, but that was the basis of it. Now, the laws of probability, the sum and the product rules they're called, which Cox derived, they've been known for about 300 years, but what Cox did put them on an altogether deeper, more fundamental basis. I think it's one of the great papers of the 20th century, and I profoundly wish it were better known.
Just tell us what the sum rule is, which I think is easy for everyone to understand.
The probability that something is true plus the probability that the same thing is false have got to add up to 1. Think of it as the probability of that somebody is guilty given the evidence. That rises at the same time as the probability that they're innocent given the evidence falls.
I see. So the significance of Cox's work is that these rules are absolutely true, so to speak. Does it have significance for how you apply probability?
Probability theory can be applied or misapplied. And I would maintain there's a whole body of work in the 20th century statistical profession called sampling theory that got it wrong. And you need to use Bayes' theorem, which plugs into something else that's interesting, if you're going to do it correctly. A lot of people, notably R.A. Fisher, thought that you wouldn't be able to use Bayes' theorem because it depended on prior information, which wasn't information that came from the experiment you were doing. It was what you knew beforehand about what you were trying to work out. And he thought that that was, quote, subjective, Fisher did. But of course, what you know before an experiment, you need to incorporate that as well, obviously. Bayes' theorem is completely correct. But the original question that you asked, Jim, In one sense, what Cox did doesn't make any difference. The laws of probability were known before Cox and they were known after, but they're on an immeasurably deeper basis thanks to Cox.
Is the take-home message that Cox gave a basis for the objectivity of probability, so to speak?
In a word, yes.
Okay. How about we move on to Jaynes? Could you tell us about actually knowing him, and then we'll go on to what the point of his work was?
Oh, that was a privilege. I was in the radio astronomy group at Cambridge, although I wasn't actually a radio astronomer. The radio astronomy group grew out of the group that I was in, and I was the last research student of the last guy in the ionosphere group. And therefore, over tea and coffee in the department, I got to know the radio astronomers. And there was a man there called Dr. Steve Gull, who was also very impressed with Ed Jaynes' work and realised that it could be used, his maximum entropy method, which Jaynes picked up from another genius called Shannon. Steve Gull realised that you could use the maximum entropy method to de-blur photographs of the sky at radio wavelengths, and that's what Steve was working on. And Steve and a colleague in the Applied Maths department at Cambridge worked up a software package that was based on all that proved to have very wide application. And boy, did it also do what they originally designed it to do, which was improve and de-blur photos of the radio sky. It's a very powerful package.
Yes. Can you give us the basics of what maximum entropy is? Because I think this was one of Jaynes's main contributions to bring that back and make it applicable to a lot of applied areas like you mentioned. So what is maximum entropy?
Whoa, that's asking a lot in a non-technical
simple example.
Essentially, if you use maximum entropy, it guarantees that you won't be putting anything into your result for which there's no evidence.
Okay, give us an example of how it works in a simple case.
Seeing is believing. If I'd known you were going to ask this, I'd turn up with some pictures of the radio sky, the raw data, and then the old-fashioned methods, and then the maximum entropy method. You'd be a believer instantly.
Mm-hmm. Okay, so the results are good.
You bet.
What does maximum entropy actually mean?
Before I answer that, let me give you another example, which is that I think in Bayesian spectral analysis, working out what frequencies are present in a signal, Ed Jaynes and a research student of his, Larry Bretthorst, applied the maximum entropy method and Bayes' theorem, and they found that they could improve on the best methods that were around at the time in the 1980s by a factor of, from memory, 10,000. Now, nobody believed them, and Ed Jaynes said ruefully in a later work that if they'd improved it only by a factor of 10, they'd have got instant recognition. There's a prime example of irony for you.
Yes. What is it? What is maximum entropy?
It came out of information theory, which was worked out by a man called Claude Shannon. And what you do if you want to work out a probability distribution among the faces of a dice that you're tossing, and you know one or two, you might know what the average is, and you know that the probabilities all add up to 1. And there's this thing called the information entropy, which depends on the probabilities of all the faces. And if you make sure that that is as big as it possibly can be, then that constrains a probability distribution.
Okay, now tell us what Jaynes was actually like to meet and to play piano with.
I'll gladly do that. And not only did Steve Gull put me onto the work of Ed Jaynes, and there was a 1983 book of selected papers on probability and statistical physics by Ed, which came out, which we all absolutely seized on. But Steve invited Ed Jaynes to come for a year's sabbatical to Cambridge. From memory, I think that would be 1983-84. And Ed was put up in St. John's College in Cambridge, which is the college where Steve was a fellow. And I officially shared an office in the physics department with Ed. Although because we both preferred to work in our rooms in college, we hardly ever coincided in that office. I did, however, see Ed at meetings which were held fairly regularly of the maximum entropy, informal maximum entropy Cambridge group, which was across various departments. We used to meet for lunch once a week, and obviously Ed would turn up at those. To my surprise, after I looked at his papers, which were written in an always courteous but punchy and extroverted style, he was a very quiet and even shy man in person. Perhaps that might be because he'd spent a lot of his time at conferences telling people that they were doing probability and statistical physics wrong. And he was right, but they wouldn't have appreciated that.
No, indeed. What about playing his piano playing?
Ed Jaynes loved playing the piano. If you look at the tribute website to him that's maintained at his old university, you'll see that he actually wrote an entire book about the physics of music. Never been published, but it's there downloadable online. And Ed was a competent piano player. The only time I heard him was at the 1985, I think, Maximum Entropy Conference, held in cowboy country, Laramie, Wyoming, where I found myself singing a Tom Lehrer song, The Wild West is Where I Want to Be, about Los Alamos and the A-bomb project, while Ed played piano. But Ed also loved the Beethoven piano sonatas, and that was another link between him and Steve Gull, because Steve plays them too.
Now, all these years later, when we're worrying about which parts of science are rational and which are somewhat flaky, has Jaynes got any message for us? What is the conclusions of his work on the problems that science has at the moment?
I don't think Ed actually drew many conclusions. He was a very dedicated physicist who just wanted to keep going and getting more and more physics. He was rather sceptical of philosophy.
Right. Hey, would you like to draw some conclusions for us?
The philosophy of science is, to put it perhaps brutally, parasitic on science itself. Scientists don't need philosophers of science in order to do science and in order to do good science, but the philosophers of science are commentators on what scientists do. I should add, when I say scientists, I'm really only talking about the mathematical sciences, physics. None of this applies to the biological sciences. And one thing that I had learned was that a whole load of my colleagues said, oh, the philosophy of physical science, Karl Popper sorted all that out. Now, I read some Popper and I wasn't impressed, but I couldn't put my finger on what was wrong at that time. And I think Ed Jaynes perhaps felt the same. It was when I met another man, David Stove, that all fell into place for me.
Yes, let's move on to David Stove, who has perhaps more direct lessons for the rationality of science. How did you meet Stove?
Well, I met David Stove because I was hoping to work with Ed after my first postdoctoral contract in Cambridge. That's Ed Jaynes, of course. But he said to me, you've asked me a bit too late. My money is deployed for the coming academic year. Come the year after. So I applied for research fellowships, essentially in my field, in parts of the world I thought I'd enjoy living. And the first of those to say yes was Sydney, Australia.
Good choice.
I certainly enjoyed living there. While I was there, Ed had a health crisis, so I was never able to go and work with him. But I got extended in Sydney, continued to enjoy the lifestyle there. And David Stove was in the philosophy department, or perhaps I should say one of the philosophy departments at the University of Sydney, where I was. And a mutual friend, Ian Bassett, who was another theoretical physicist, 2 doors along the corridor from me, he introduced me to David Stove, and we instantly hit it off.
Mm-hmm. And what about his message did you instantly recognise as good?
He explained to me in his papers and his book exactly what was wrong with Karl Popper's philosophy of physical science. And what the problem was that Popper insisted that physical science was deductive and that you could prove a theory wrong but that you could never prove a theory right. Now, that struck me as completely crazy. You cannot go to a physics department, open the tea room door, and find a whole load of people saying, "Hey, I'm delighted, my theory was proved wrong by somebody today." What all scientists want to do is find that their theory is proved provisionally correct, not wrong. So it's a complete inversion of reality, of the way scientists think, what Popper was saying. And I realised that the problem came out of Popper's commitment to deductivism and his rejection of inductivism. Now, I believe that inductive logic, when done correctly, is identical to probability theory when done correctly. Both of them, sadly, are often done incorrectly, but done correctly, they're one and the same thing.
Yeah, so you believe that physicists, generally speaking, use inductive logic and do it quite well?
Well, yeah. I mean, if you want to compare Einstein's theories of relativity, of how something moves and the acceleration imparted to it by a force, and compare that with Newton's, the two start to differ when you get up near to the speed of light. And what goes on is that it's just a very, very large-scale example of comparative hypothesis testing. Now, hypothesis testing is something that you need probability for.
Right.
The problem was that because Karl Popper did actually accept probability, although I don't think he understood it correctly, and because he rejected induction, and because probability and induction done correctly are one and the same thing, the basis of Popper's arguments are incoherent, and it's very, very difficult to argue with incoherence. Well, Popper got his hostility towards deductivism from a philosopher who talked sense on most subjects, but not on probability, called David Hume in the 18th century. And Popper perhaps picked that up and ran with it in his methodology of how science works.
Mm-hmm. So would you say that there are other areas of science or alleged science where that fail to do things rightly inductively?
I would say that the problem occurs, when there are different schools of thought at the research frontier on what's going on, and it's legitimate to have different schools of thought at the research frontier. It wouldn't be research if we knew exactly what we were doing, as Einstein is supposed to have said. But one of those schools corners all the grant money and gets a monopoly on it. But it might not be the school that's correct. And then that can set science back a generation.
Would you like to name names? String theory, climate science, whatever?
Both of those, in my opinion.
Okay. Any more?
Those will do.
No, it's enough to be going on.
Yeah.
Okay. So tell us about knowing Stove. I mean, what was your interaction? How did you find his personality?
Again, David, like Ed Jaynes, was quiet in person compared to his on-paper persona. He was also very Australian of a particular sort. He'd loved England when he'd come over to my country sometime before. I guess it's fair to say that David was a more rounded personality than Ed.
Oh, rounded, yeah. In what way?
I think Ed Jaynes was shy. David wasn't. He was just quiet.
Okay, yes, yeah. But then what did you discuss with him, apart from the evils of Popper?
Over lunch at the faculty club, he held court at a table, and I went there to dine with him and talk with him and his colleagues once a week. And he would sit there drinking 2 bottles of Cooper's, which was at that time Australia's only live beer, and rolling hand-rolled cigarettes. And then when everyone had turned up, we'd go and get our food and discuss it. It was always fascinating to hear him talk on many areas of philosophy because although we were both interested in the philosophy of science, we completely agreed about Popper, but we didn't fully agree about probability. And we both considered ourselves expert at it, and we, I think, tacitly realised that it was better not to discuss that. We did that through the university's internal mail. This was before email, of course. It was fascinating to hear him talk about other areas of philosophy.
Such as what? Had some criticisms of some of the great minds, allegedly great minds.
One or two. I think that this was the stuff that appeared in a later book of David's papers called The Plato Cult. Afraid I can't remember much in it off the top of my head.
Okay.
I know that he was very critical of the European Rational Enlightenment project, which initially surprised me because he had a great love of applying rational thought to human endeavour, but he thought that it was bound to go wrong. I'm not sure that we ever really engaged on that. It fascinated me.
Yes, he was a very Enlightenment figure himself, in that he loved 18th century literature and loved David Hume's writing. But yes, he felt that something had gone very wrong with the improvement project. So I suppose you'd say he had a pessimistic view of any projects to change anything, including Enlightenment projects and any modern revolutionary projects.
David was a pessimist,
Yes. Pessimist about... So he had an argument, didn't he, about why you should be a conservative, that said that while in principle a change could be good, that the chances of any given change being bad were almost towards certainty.
Yeah, I think that was in one sense a simplistic argument. Perhaps all the bad alternatives had been tried earlier on and rejected in an era when people had better sense about what would and wouldn't work. That plugs into all sorts of deeper preconceptions about people in the Enlightenment era.
Do you remember him having stresses and fears at that time? We're talking about the 1980s, right? About what we now call cancel culture, but what was there but not called that then?
Well, as I recall, David got a letter of discipline from his university for telling the truth about some appointments in the other philosophy department in Sydney, because there'd been a split into the department of philosophy that David was in and the department of philosophy that all the Marxists and the academic feminist philosophers were in. I entirely agreed with David. He wrote a 4-pager which he put into something called Quadrant magazine, called A Farewell to Arts, about how what was then called political correctness and is now called woke was wrecking the humanities in the universities of Western civilization, and I fear that it is coming to pass very quickly. They're ceasing to be bastions of freedom and are now becoming places where you can't speak your mind, where you're liable to be sacked if you speak your mind. It's disgraceful.
Yes, things have become very bad in that respect. Now, just to sum up, looking back over Cox, Jaynes and Stove, can you give some kind of summary or overview of what their joint message is from the point of view of how to evaluate which science is good and which science is broken at this stage?
That's a tricky question.
What have we learnt from them? I mean, they were all saying something about the objectivity of probability and how to get that right and how to apply it. So what to conclude for science as we see it now, about evaluating its credibility, or the credibility
the question,
of which
I guess,
parts are
is
good.
Who is to evaluate its credibility? And as with scientific journals, there really isn't much of a better way than peer review, but it's not a very good way. It often works very well. For example, there was a chap called Jan Henrik Schön who was shown to have falsified results, and he was detected within 5 years in solid-state physics. I thought that was an example of science working well. But sometimes it doesn't, as I said before, when there is legitimate uncertainty up at the research frontier and one aggressive school of thought grabs all the grants.
Yes, that's right. And you'd probably say solid state physics is about the most solid science there is, by and large, wouldn't you?
I think that's in good health at the moment, yeah.
Okay, good.
And I think astrophysics is in good health because it's very data-driven and technology continues to improve wonderfully and therefore gets the astrophysicists more and more and more and better and better and better data. I sometimes have concerns about what you might call quantum cosmology, some of the stuff about the very earliest microseconds of the universe, and it seems to me that sometimes some of the papers that get written there are verging on science fiction.
You think we've reached the edge of what we could reasonably know? Is that what the problem is?
Yes. Now, no one's going to be able to set up another universe and look at it.
It's not a very
by definition, there's only one universe.
Not a very predictive science, right?
I think we need to learn to walk before we can run and look at what's going on a bit more deeply in quantum mechanics before we try to unify that with Einstein's theory of gravity and apply it to the very early universe.
Okay.